So TR's demo was what I would call an active diamagnetic levitation system, because you could adjust it and all that. And it would, I mean, that's the best gapping I've ever seen of any demo. This one is not quite as good gap-wise, but this is a passive system, and like TR observed a little short time ago, it's opposite of what he showed. And here we have the magnet array. This is a Halbach array. And here, if you want to know a little bit more, I have a 5-page paper. I didn't bring it, but it's available. I can send it to you. But it shows the actual magnet array. And to put these magnets on a steel plate was a really a function, being very careful and being patient. And I had to use things like aluminum spacers, wood spacers. For example, I would slide the magnets onto the steel plate, you know, one at a time with basically a thin piece of wood. And it just was really difficult to do. But they're on there now, forever. And you see one back here chipped. Because again, if you're not careful, you can chip these magnets. They're very brittle. But on here you have little slices of pyrolytic graphite, like TR used in his demo. And these are, again, it's just opposite. We're floating them on the magnets, and they kind of pin on the magnets. And then there's a dead alien skeleton on top. It's really a cicada shell. I had some cool spiders, but they were too heavy. Not real spiders. You know.
Hey Tim, I've done this before. I used to put ants on a thing that's
Oh, ants would be cool.
And they'd run around, but they could never get off.
Oh, that'd be funny. So then that's really just to show you, you know, the passive technique of diamagnetic levitation. And one more thing before I continue is look at the backing plate is part of the magnetic circuit. And you say, well, how thick does it need to be? Well, K&J Magnetics has a simple online analysis you can do where you put in the magnet alloy material, in this case N42, and that's really approximately 42 megagauss Oersted. And then the dimensions of the magnets, 1 by 1 square, 1/2 inch thick. And it comes out to 0.47, or just under 5/32 of an inch thick. So this is really overkill, but it doesn't detract from, you know, the actual performance of the circuit. You know, more with the magnetic circuit, with all things being equal, you know, more steel is better. And so that's about it. But we can take these off, and you guys can play with the Lenz's law.
Slim picking. Yep.
And we'll just go. Oh. We'll do the Lenz's law. So here's a magnetic film. So it really kind of shows you this, and it's a heavy.
What you need to do is get a strong enough magnetic field that you can go ahead and levitate small animals.
Yeah. Small children. Children too.
The bitter solenoid they were floating frogs in.
So here's a magnetic pattern from the film. And I guess it's little ferrous particles within a polymer that enough. They're mobile enough to deform. And here's some cards. I think you guys have seen these before.
Yeah, it's neat.
Yeah, just kind of let you see the magnetic field. And these work on, obviously, on any magnet. And this is a piece of copper disc. And if you want to come up here and test Lenz's law,
It's gonna be tough.
and see how difficult it is besides the mass here.
Yeah, just setting it down, you can see that it's slower than
I know how it
gravity.
feels. I always like doing that.
Yeah.
Anyway. Yeah, it makes ooh wow.
Now, if Richard I'm not sure if Richard has something like a razor blade, I can show you how you can slice
I have a razor blade.
pyrolytic graphite
I have a
lengthwise.
razor blade.
Okay.
Do you,
I have a razor
Hey Tim,
blade.
we're gonna head out. I'm not feeling
Somebody
good.
else wanna
Okay.
try it?
Well, I hope you feel better.
Yeah,
Try
I
that.
just wanted to see your demo. I appreciate
Yeah,